Unit 1, the alphabet and grammar of geometry. Preview video 1.0, Algebra Review-Variables. Take the time to do this, students. We're going to do this twice. Ready? Inhale through your nose. Hold for 3. Exhale 5. Inhale. Hold for 3. Exhale 5. Last time, close your eyes. Ready? Inhale. Hold. Exhale slowly. Your eyes. You should have your preview videos right in front of you. Don't forget to record the location, the date and time. Right here, location, date, and time. And don't forget, either you need to get a parent, a teacher, a guardian, or some sort of adult who witnessed you doing these sign off. Please, I beg you, turn off all other distracting devices. Do not attempt to multitask while you are doing these videos. Turn off your phone, close all the toggles and the tabs that you have. You should not be playing video games while you're doing this. And you should also have AirPods in your ears so you're actually listening and doing together. Just a quick couple connection devices. Number one, I highly recommend you subscribe to my YouTube videos, YouTube channel. By subscribing, you'll be alerted immediately when I load up videos related to this class. So you want to subscribe to this channel. 2, remember to subscribe using your cell phone, the Remind 101 text. Late homework issues, I already talked about in class. You should read about that in your syllabus. I'm available for tutoring 1A, 1B every morning, Monday, Wednesday, and Thursday during lunch. I must also add Monday and Thursday during warrior time. So we already talked about subscribing to my video channel. Students, if you are A-Day, you should subscribe to the left-hand side. If you're B-Day, you subscribe to the right-hand side. Please look on your video notes for that. For this class, for geometry class, there are essential previous math skills, 3 essential previous math skills you need for this class, 3 as related to variables. You need to be comfortable computing math with fractions. You need to be okay solving for a variable. And I'm also going to recap something called lattice multiplication, because in this class, very frequently, you are not going to be allowed to use a calculator for your computations. Pretty much only when we're doing something called Intro to Trigonometry or significant decimals, you're allowed to use a calculator, but for the most part, you will not be allowed to use a calculator for this class. Number 1, we're going to talk about dealing with fractions. One of the primary mistakes is when you can cancel fractions. Take a close look where the equal sign is here. On the left-hand side, we're simply multiplying 2 fractions, and they are going to equal a product. On the right-hand side, you have fractions on either side of the equal sign. So when your fractions are on the same side of the equal sign, you can cancel to your heart's content. For example, 4 goes into 12 3 times. Three goes into 6 twice, 3 goes into 9 3 times. Once you have canceled, then you just multiply straight across. And you can see that we can actually still reduce one more time. So the final answer of 4/6 times 9/12 is 1/2. Over here on the right-hand side, you cannot go across an equal sign and cancel. What I visualize this is your backyard and this is your neighbor's backyard. You cannot go across your neighbor's yard and take stuff away from them. 3 goes in there 3 times, 3 goes in there 4 times. You cannot cross the equal sign, cross the neighbor's fence and steal stuff from them. No, you may not, but you can be a super nice neighbor and you can multiply your neighbor's goods. So we can cross multiply like this. 9 times 12. And then 4 times x. And when you cross multiply, I want you to get in the habit of actually drawing that x in the middle. Now, here's a key thing. Why didn't I multiply 9 times 12? Because the key to multiplying is to not multiply. It's to factor. Let me say that again. The key to multiplying is not to multiply, but to factor. So instead of doing 9 times 12, and getting a singular number, I simply leave it at 9 times 12, and I'll show you why. It's easier to factor this out when you're leaving it in those two pieces. We're going to divide by 4. Four goes into 12 3 times. Now I can multiply. And I can check. So on the left-hand side, 4/12 reduces to 1/3. On the right-hand side, 9/27 reduces to 1/3. There's my check. The key to multiplying is to not multiply. It's to factor. For dividing, when you divide fractions, all you do is you multiply by the reciprocal. So 5/9 divided by 10/12. It could also look like this. 5/9 divided by 10/12. Instead, we're going to multiply by the reciprocal. So 5/9 times 12/10. Because we're on the same side of the equal sign, you can cancel. 5 goes into 10 twice. 3 goes into 12 4 times. 3 goes into 9 3 times. Now you multiply straight across. This is 4 over 6, and I can reduce that one more time. Divide both by 2, and I get 2/3. That's for multiplying and dividing. For adding and subtracting fractions, just to give you a little recap, you want to get them into alike denominators first, and we're going to do that using a process I call arrow in, arrow out. You first establish what the lowest common denominator is, the LCD. And of 7 and 2, the lowest common denominator between them is 14. So I'm going to put a little 14 here. I call this arrow in, arrow out. Ready? Draw the arrows with me, please. Arrow in. 7 goes into 14 twice. Arrow out, put a little 2 there. 2 times 5 is 10. So that's going to be 10 over 14. Plus, arrow in. 2 goes into 14 7 times. Bring down the 7. 7 times 1 is 7. So 7 over 14. Now you add straight across. Add, not multiply. It's going to be 7 14ths. Can you reduce? No. And you are done. Subtracting. Again, I'm looking for the lowest common denominator of 4 and 6. And that's going to be 12. Arrow in. 4 goes into 12 3 times. Bring that little baby 3 around. 3 times 3 is 9. So I'm going to go 9 twelfths minus 6 goes into 12 twice. Bring the 2 around. Now that you have the same denominator, you can subtract straight across. The answer is 1/12. Most of what I'm doing should feel like a deja vu, like, oh yeah, I remember how to do this. If you are very uncomfortable right now, I highly suggest come see me for a little extra help. During tutoring, I'll happily give you more practice problems so that you are extremely proficient at this without ever being intimidated by fractions again. This page, when you see this icon, this is what you do. In a moment, you're going to pause the video. You're going to do this page on your own. And then you're going to restart the video when you're done. And you're going to have a red pen ready to correct your work. Use a pencil right now. So right now, you are using a pencil. Ready? Pause the video and do your own work. All right, students, you can speed ahead just to the answers if you want, correcting with your red pen. If you have trouble at any time, slow the video down into real time so that you understand what's going on. Again, you are correcting your work with red pen. This you could have cross-canceled. So because we're on one side of the equal sign, that goes in there 4 times. That goes in there 5 times. Multiply straight across. You should have gotten 4/5 as your final answer. Here, you cannot cross cancel. You must cross multiply. So we're going to go like this. 36 times 3 equals 12 times x. Key to multiplying is to not multiply, but to factor. That's why I didn't actually multiply 36 times 3. I'm going to divide by 12. Now I'm going to reduce here. I know 12 goes into 36 3 times. So my final answer here is going to be 9. So if you're correct, I expect some sort of celebratory marking, some sort of star, maybe a check, I got it correct, smiley face, something if you're correct. If you're incorrect, I expect to see the redo of the problem as well as a written explanation, a short sentence or phrase. What do you what do you want to remember? Next time. I expect to see that on your video notes. It's okay, totally okay if you got it incorrect. Just write down how to do it as well as a phrase or something you want to remember from this problem. Here, you should have flipped it. So we have 8 over 21 and times 14 over 64. Now you can cancel. 7 goes in here twice. 7 goes in here 3 times. Multiply straight across. I have a 2, a 3, and an 8. I can reduce this. So your final answer should have been 1 over 12, 1/12 there. And on this, you first find your LCD. Our LCD is 18. Put an 18 right here. Arrow in, arrow out. 9 goes in there twice. This is 10 over 18. Arrow in, arrow out. 2 goes in there 9 times. 9 times 1 is 9 over 18. Subtract. 10 minus 9 is 1 over 18. Again, if you got this correct, star, smiley, check, something positive. Or if you need to remember something, write yourself a note. What do you want to remember? Now we're going to go through solving for variables. You did this a lot in algebra. I'm just going to show you a couple tricks of the trade that I would like you to use for this class. And we're going to follow. When you actually plug something in to do computations, you follow PEMDAS. But when you're solving for a variable, okay, we are going to start with our parentheses. Number 1, anything on the outside of the parentheses, we're going to circle and draw distributive lines. Circle, draw distributive lines. Anytime you collect like kinds, I want you to use some sort of notation of underline, double underline, circle, square, some sort of what I call physical collect notation. I'm going to use 1 underline for anything with a variable. So this is going to be 10K. This is negative 1K minus 6 because it distributes to both. That plus 8K, that plus sign carries over to here, plus 24. Now I'm going to do physical collect again. I'm going to underline my variables. That's basically 8K minus 1K, so that's 7K. I'm going to double underline my numbers. That's 24 minus 6 plus 18 equals 10K. You want your variables to one side and your numbers to the other. So minus 7K, the opposite of addition is subtraction. This right here is multiplication. The opposite of multiplication is division. So K equals 6. It's really nice when you solve for a variable. If you ever want to check it, you simply plug it in. So for example, we can do a check right here. We're going to go negative 6 plus 6 plus 8 times 6 plus 3 equals 5 times 6 is 30. So we're going to go 30 plus 30. 6 plus 6 is 12. So this is negative 12 plus, and 6 plus 3 is 9. 9 times 8, that's 72 equals 60. And 72 minus 12, 60, 60, check. That's how you check your work, solving for a variable. Not only do you have to solve for a single variable, sometimes you have to isolate a variable. Isolate, you're not actually solving, you're just getting a variable by itself. Most commonly, you're going to be trying to get an equation, this is what's called standard form, into slope-intercept form, also known as y equals mx plus b. So your goal here is to get y by itself. So I have a storyline for this. You don't like the storyline, chuck it, forget it, come up with your own method. But this is my storyline because it helps. Silly storylines often helps memory. So here is my storyline. This is Guy Y, and he has a date, Gal 12. So they're a date, keep that in mind. Minus, and here we have Gal X and Guy 4, and they're a date. And then you have a very brave, no date, but I'm going to show up anyway to the party person here. My storyline is this. Guy Y gets some sort of attitude, whatever it is. I don't like the music. I don't like the food. People aren't friendly. So, and he gets some attitude and just kind of projects it. Okay. Everyone wants to get away from Guy Y with the attitude. Okay. Now you ask yourself, who leaves first? This room. 12's not going to leave first because 12 is the date. The 12's going to try to stay. Oh, honey, please, let's stay. I got all dressed up. I did my hair. I did my makeup. I don't want to leave. Okay, so the date is going to try to stay. But the other couple, they're like, I don't want to watch a couple meltdown. So they're going to remove themselves to the other room. This is positive. We take the entire couple by subtraction, opposite of addition, over to the other side. This is important. Single person, date, they do not interact. Okay, if you ever notice very often at a party when all the couples kind of talk and all the singles kind of talk in their own group, in life that kind of happens, but in math, this is not going to become 32x. That's a no-no. Okay, that's single, that's a date. They don't mix and mingle. So I'm just going to leave it like this. Okay, back to our storyline. Guy Y still has an attitude. His date, -12, says, I'm finally done with the attitude. I'm going to go find other friends. This is multiplication. You do opposite. We're going to divide. And this is really important to both my example, really important to life. She's not going to go into the other room, and I do not want to see this. I do not want to see the 12 under both of them like this. That's like a girl going into the other room and announcing, my date's a jerk. I'm leaving him. Okay, that doesn't happen generally. Instead, she's going to quietly gossip to each individual term. She's going to go here. Did you hear what that guy did to me? Oh, he's such a jerk. And she's going to go each term individually and gossip, because us gals love to gossip. It's kind of a pastime. And so now we have y, 36 divided by 12 is 3. That's negative, minus, and this reduces to 1/3 x. And you want to bring it around and make it look like what you're used to, y equals -1/3 x minus 3. Y equals mx plus b. Isolating a variable. This page you do on your own. Pause the video, restart when you're done. Welcome back. You should have your red pen ready. And if you want to speed through the answers and just check your work, you can hit double time at this point. But those who would like an explanation, keep it in real time. So right here, I'm going to take that 8 and distribute. Notice I'm circling distributive lines, -7x plus, It's 8. That's negative 8x equals negative 8x. Double negative makes a positive. All right, now I'm going to collect like terms. Single underline my variables, double underline my numbers. You can use circles and boxes if you want. All right, that's negative 7x minus 8x, and that's negative 15x plus 8 equals negative x plus 1. Goal is to get variables to one side, numbers to the other. So I am going to go plus 15x plus 15x. This cancels. Minus 1, minus 1. That cancels on the right. 8 minus 1 is 7. 15 minus 8 is 7x. Divide by 7, and you get x equals 1. Isolating the variable here. Y has an attitude. Everyone's trying to get away from Y. Couple leaves first. Then the date, opposite of timesing, is dividing. Remember, she gossips to each term. She goes to each term individually. We're going to reduce here. We have y equals 3 goes in there twice, 3 goes in there 3 times, x minus 3 should have been your answer. In addition to dealing with the variable, I'm going to go over what's called lattice multiplication, because I expect you to use lattice multiplication for 1, 2, and 3-digit multiplication. You may not use a calculator for 4th grade math. So I'm going to go over this page. Some of you may not have been exposed to this, so I'm going to go on the slower side. But once you learn how powerful this is, it is amazing. If you need to, keep your times tables in front of you. If you don't know your 1 through 10 times tables. So to do lattice, step number 1 is to establish a box with the correct number of terms. We have a 2, what's called a 2 by 2. So 2 across, 2 down. So if I were to draw this, I would simply draw a box and I would make it as even as I could, 2 by 2. And then I would connect the corners. I'm just showing you how you can do this on your own. It seems like a lot to set up, but once you set it up, so easy. Ready? We're going to go 45, 68. I'm going to put it on the side here too, so you can see how you would do it without the lattice paper. Okay, now you multiply the individual digits. 5 times 6 is 30. The upper is the tens place. The lower is the ones place. So 5 times 6 is 30. So I go 3 for the tens, 0 for the ones. Then I'm going to go over here. 4 times 6, 24. That means 2 for the tens, 4 for the ones. 5 times 8 is 40. That's 4 and 0 for the ones. 4 times 8 is 32, so 3 and 2. And then over here, it would look exactly the same. 40 and 32. Then you simply multiply along, add along the diagonals to get your resultant. Okay, so this is going to be 0. And 2 plus 4 is 6. This is 7, 8, 9, 10. So that's a 0. You carry the 1 and 3. So 45 times 68 is 3,060. Woo! Look at that, 2-digit multiplication without a calculator. Let's up our ante here. Now I know the vast majority of you had this on a test 2 digits by 5 digits, you'd be grabbing calculators. I want you to get out of the habit of doing that. You are intelligent. You can do this. So we're going to go a 5 by 2. 1, 2, 9, 8, 7. 1, 2, 9, 8, 7. Make sure you write that down correctly, 94. Ready? This is where you need to know your times tables. 7 times 9, 63. 9 times 8, 72. 9 times 9, 81. 9 times 2, 18. 9 times 1 is 9. That means there's a 0 in the tens place and a 9 there. Now we're going to do the 4. 4 times 7. 4 times 8. 4 times 9. 4 times 2 is 8, so there's a 0 and an 8. 4 times 1 is 4, so 0 and a 4. Now, add again, down the columns. It's 8. 3 plus 2 is 5, 6, and 7. 2 plus 6 is 8. That's 11. 17. Make sure you carry the 1. That's 8, 9, 10, 11, 12. 12 plus 8 is 20. Carry the 2. 2 plus 8 is 10. 18 plus 4 is 22. 2 plus 1 is 3. Plus 9 is 12. Carry the 1. And now we're going to write this down. 1, 2, 2, 0, 7, 7, 8. Don't forget your commas, 1, 2, 3, comma, 1, 2, 3, comma. So 12,987 times 94 is 1,220,770,800,000. Aren't you brilliant without a calculator? It's amazing. Ready? Now, amazing magic. We're going to do it with decimals. Look at this, with decimals. And I know so many of you, if you were given like this, you'd be grabbing your calculators. No, we're going to set it up. It's a 2 by 2, so 2 by 2. Here's your decimal. There's your decimal. Now you do it the same way you did before. 7 times 4, 28, 12. That's 7, so 0 and 7. 1 times 3 is 0 and 3. And you're like, what do I do with the decimal? Here's the trick with the decimal. There's only one decimal. You carry it straight down along the diagonal. If there's 2, you see where they meet. They meet here. And you bring it down. So your decimal is going to go right at that spot. Watch the magic. 7, 11, carry the 1, it's 5, 15. So this complete answer is going to be 15.17. Now I know a lot of you are like, no way, it's not that easy. Get out your calculator, go ahead and check your work. This page, you're going to do completely on your own. Watch out for those decimals. Ready? Pause the video. Welcome back. Students, you really should have done that on your own. You should have a red pen. You can hit double time and speed through just the answer to correct your work, or if you want an explanation, keep it in real time. So in real time, I have 28.2 and 18.9. So this is a 3 by 3. Ready? 2 times this, that's going to be 2. 2 times 1, so it's 0, 2. 2 times 1 again is 8. 2 times 1 again is 2. Next column, 2 times 8, 16. 8 times 8, 64. 2 times 8, 16. 2 times 9, 18. 8 times 9, 72. 2 times 9, 18. Now, I bring down my diagonals. That's 8. 7, 8, 9. That's 3. Plus 4 is 7. Plus 7 is 14. Plus 8 is 22. 8 plus 2 is 10. 16. 22, 23. 2 plus 2 is 4, 5. And then this is a 0. Bring down the decimals. My decimal goes from here to there, hits that diagonal, and boom. 28.2 times 18.9 equals 532.98. Ta-da! Now, students, for your last video, we've gone over a lot of material here. What I would like you to do, please, is take a moment and using this page, summarize 3 main concepts you want to remember. 3 main concepts. You can use short phrases. You can use symbols. You can draw a little diagram if you want, but I would like you to summarize what 3 main things you'd like to remember from today's lesson. Good job.